High voltage open bus. Introduction. High voltage open bus are air-insulated, current-carrying conductors, clamped to insulated supports as in the case of switchyards. Open bus bars find applications both outdoors and indoors and in AC and DC systems. The present discussion will primarily focus on rigid aluminium conductors installed in outdoor switchyards. Before the introduction of the gas-insulated switchgear, a few high-voltage switchyards in coastal areas, exposed to winds and salty atmosphere, and areas with heavy pollution had been housed in buildings. The high-voltage lines entered and exited the building through high-voltage condenser bushings or by cables. Switchyards with a rigid bus are more compact with a low support structure and lesser phase-to-phase clearance when compared to those with strain bus. However, a strain bus offers better seismic force withstand capability than a rigid bus. The cost of the bus bar, aluminium alloy tubular conductor, as a percentage of the total cost of the switchyard equipment comprising circuit breakers, isolators, instrument transformers, surge arresters, line traps, insulators, and support structure is very small. Hence, sizing of the bus bar is always on the conservative size. Hot spots and corona discharges, if observed, can be attributed to improper selection and installation of clamps and connectors. Description. These bus bars are primarily installed in the outdoor high-voltage switchyards rated 36 kV and above. The rated voltage of AC and DC switchyards and transmission lines has reached the 1.5 million volts milestone. Conductors in switchyards can be multi-layered and can be designed with strung conductors or rigid buses or a combination of both. Switchyards with rigid buses seem to provide the most optimum and cost-effective solution. Switchyards are located at generating stations, where the power is evacuated. Over a period, with the expansion of the power plant, installing additional generating units, the voltage of evacuation may increase. It is not uncommon for a generating station to evacuate power at different voltages. Receiving and switching stations, where lines from various generating stations and other receiving and distribution stations get interconnected. These substations may have interconnection between lines of different voltages facilitated by auto-transformers. Load stations, where the power is consumed by major load centers such as process plants, mining and extraction plants, utilities, and urban areas. Many consumers may have captive generation within the plant to cater to the load and export power to the grid during lean demand. Switchyards are characterized by the rated voltage. Countries all over have adopted different voltages for power transmission and distribution. ANSI/IEEE and IEC have different preferred rated voltages for medium voltage, high voltage, extra high voltage, and ultra high voltage systems. Minimum phase clearances, sectional clearances, and ground clearances vary with the rated voltages, are well defined in standards, and, in some cases, are project-specific. The voltage rating for a switchyard is classified as follows. Medium voltage, up to 72.5 kV. High voltage, greater than 72.5 kV and up to 245 kV. Extra high voltage, greater than 245 kV and up to 800 kV. Ultra high voltage, greater than 800 kV. There is no standard configuration for different types of bays such as line bays, transformer bays, bus coupler bays, bus transfer bays, in a switchyard for a given voltage. Since the basic power components are well defined in a specific bay, there is a broad agreement on the layout. Many utilities have a standardized layout with associated components as it helps them maintain a low inventory. Material. The conductor materials used in a switchyard are copper or aluminium in the shape of copper tube, copper wire, aluminium alloy tube, aluminium wire, all aluminium conductor, AAC, all aluminium alloy conductor, AAAC, aluminium conductor alloy reinforced, ACAR, and aluminium conductor steel reinforced, ACSR. Of these, aluminium alloy tubes are the most preferred and are the most commonly used material in switchyards. All the accessories such as clamps, connectors, bends, laminates, end caps, corona rings are all made of aluminium castings or fabricated from aluminium alloy sheets and extrusions. The conductivity of aluminium alloys is expressed as %IACS, International Annealed Copper Standard. Aluminium sheets 1350, 65%. Aluminium tubes 6101, 55%. 6063, 53%, 6061, 41% of different tempers. Aluminium casting, LM25, 39%. Aluminium tubes can also be extruded from other alloys that are resistant to corrosion in coastal areas or locations with severe industrial pollution. Shape. Circular tubular conductors are always chosen for a high-voltage switchyard. The reason is very obvious. It minimizes corona, audible noise, and radio noise. For a given cross-section, it has the ideal shape for strength and ampacity. Its section modulus is the same along any radial axis and ideally suited to withstand loads due to self-weight and ice load, wind load, and short-circuit loads that act in different planes. It can be negotiated to any shape to meet the phase spacing and differences in elevation of various connected equipment. It provides an aesthetic appearance. Operating conditions. Bus bars, clamps and connectors, and insulators are static devices and require the least maintenance, if not maintenance-free. Any abnormality in the switchyard connections due to improper installation can be recognized and rectified during the initial days after commissioning. The bus bars and accessories are exposed to vagaries of nature such as variations in ambient temperature, pollutants, solar radiation, rain, snow, ice, storm, and wind. The impact of these increases with the increase in the rated voltage of the switchyard. The ground clearance, phase spacing, and the height of the conductor from the ground increase with the increase in the rated voltage. These need to be understood while sizing the conductor and the supporting arrangements. The ampacity is significantly impacted not only due to variations in the ambient temperature but also due to wind and solar radiation. The conductors are subjected to unidirectional and vibrational force in different planes due to the wind, short circuit, and thermal expansion. The conductors will be directly exposed to the corrosive and saline atmosphere when installed near certain specific plants and seashore. They will be more susceptible to chemical and galvanic corrosion. Medium voltage, high voltage, extra high voltage, and ultra high voltage switchyards generate corona discharge. Thank you. Mr. Balachandran graduated with a bachelor's degree, B.Tech, in electrical engineering from the Indian Institute of Technology, Madras, India, in 1967, and obtained a master's degree, M.E., in power engineering from the Indian Institute of Science, Bangalore, India, in 1970. He is a Fellow of the Institution of Engineers, FIE-India, Fellow of Institution of Engineering Technology and Chartered Engineer, FIET-UK, and Life Senior Member of the Institution of Electrical and Electronics Engineers, IEEE-US. He was the founder-director of Power Gear Limited and Busbar Systems, India, Limited. He has worked in manufacturing industries in India and the UK and is currently an advisor. He has engineered several busbar systems that have been manufactured and installed in various countries, including isolated phase bus for the largest hydroelectric power plant, 26 by 800 megawatts, at the Three Gorges project in China. During his professional career, he has developed and tested a range of bus products and their accessories. His area of interest also includes switchgear, instrument transformers, and power system analysis. The book, An Introduction to Busbar Systems, authored by V. Balachandran, is case-bound, hardcover, size A4, 386 pages, printed on 100 GSM glossy paper. Copies of the book can be purchased with a requisition to Bala at busbarsystems.net. Black and white version of the book is for sale in India, Afghanistan, Bangladesh, Bhutan, Nepal, Pakistan, and Sri Lanka at a cost of 4,500 Indian rupees plus freight. Color version of the book is for sale in all other countries at a cost of US $126.00 plus freight.